Let's say you got an idea for a project. You want to start by setting up a home web server. Simple but powerful and with all the options that you need to configure your web page, your databases, your repositories, call it. Well, I just happen to be in the same situation. So let's just do it together. Alright, this is the hardware I've made. It's basically just a small board with 2 Raspberry Pis, a solid state hard drive and a power supply. I've also included a small voltage meter to make sure that I'm getting a good supply of 5 volts for the Raspberry Pis. This one is going to be the main device, so to say, for now. Meaning this one's going to be running the web server with everything, database, everything. And this one is a backup for now, and it's also going to be used for other things later on. This one is Raspberry Pi 3 Model B, first version, and it's not going to use an SD card, but instead I'm going to boot directly from the hard drive. And this one is Raspberry Pi 2, and it will have an SD. This, as I said, is mostly for now just sort of a backup, so when I'm taking this down for maintenance or some other task, and also for tests and other little things that I plan on doing. So let's configure that. First, we should note that only some of the more current models of Raspberry Pis will be able to boot from USB as listed in the official page. In my case, since I'm using a Pi 3 version B, I must enable the USB booting, as it's not enabled by default. To do so, a series of commands are listed in this very same page, which will write to the onboard one-time programmable memory upon rebooting. The process is completely straightforward, and although most people report that it usually works flawlessly, I had to reboot 2 times before it actually worked. Once the Raspberry Pi is ready to boot from USB, the next step is to prepare the SSD. From the official site, we can download a zip with the latest version of Raspbian, which at the time of this video was Buster. There are several ways of copying Raspbian to the SSD, and probably the easiest is through the use of a software called Etched, which can be freely downloaded and is available for Windows, Mac OS and Linux. I will put links to all these downloads down below in the video description. Once Etched is downloaded, simply open the image, a zip file in this case, select the target drive, make sure to select the right one or you'll risk erasing another device, and click flash to begin the process. This will take no longer than a minute if you have a fast drive. Now we have a Pi that can boot from USB, so we just need to configure it properly. Using the terminal, we can configure a few options that are needed. First, the hostname, according to your domain, in case you have one. Then proceed to enable the SSH server. It's interesting mentioning that you can also do that by placing a text file in the USB device. Make sure it's set to boot to a command line interface, as we won't be needing the graphical capabilities. And last, set up the local stuff such as country, time zone and keyboard layout. As a side note, I will mention that you don't need to use the option to extend the file system as you normally do with SD cards. The hardware is all ready now, so you can comfortably log in from your computer using SSH and install all the basic stuff you might need, including Apache. Once your web server is running, the next thing is to get an SSL certificate for your domain, so you can offer secure connections. Traditionally, you had to get a certifying entity to emit a certificate for you, which incidentally costs a considerable amount of money. Things changed in 2014 with the advent of Let's Encrypt, a California-based non-profit certificate authority which will provide you with your own certificates for free, including easy and automatic renovations. To get your own SSL certificate for free, simply go to certbot.eff.org and follow the instructions. You will have to install a couple of packages, enter some info regarding your domain, and you'll have it running in a matter of minutes. After that, I recommend also setting up a bot to get your certificate renovated automatically before it's due, as explained in the same page. Although the instructions to get the SSL certificate are reasonably simple, I thought it would be a good idea to have a run through the steps so you can see how it should look when it succeeds. When you launch the certbot from the command line, you will be presented with a list of hosts that your Apache server has available. In my case, I have configured multiple virtual hosts since I intend to use this machine for several purposes. I will then say that I want a certificate for all of them. Since I've done this before, it asks me if I want to reuse the existing certificate or create a new one. Although you can ask for a new one, you are limited to 5 renovations a week, so you should not ask for a new one unless you actually need it, for example when changing or adding new domain names to your system. Finally, it will ask you if you want to redirect the unsecure connections, to which I strongly recommend you say yes, so all traffic is secure. It will then proceed to generate the necessary configuration and report back if something went wrong. And with that, you should have a fully working web server that only accepts secure connections and has a valid SSL certificate. The last touch is to verify that the automatic renovation will work, so you can be sure that you will get a new certificate before the current one expires. Run the command to launch the certbot program and try the renovation process. In a matter of seconds, it should tell you that your certificate is still good and that it can be renovated when it becomes necessary. Finally, we'll simply verify that this renovation bot is scheduled to run every day. For that, we'll check the system timers and make sure that it's listed as a recurring task. The last thing we need to do before our server is visible to the world is configure our router to forward the HTTP and secure HTTP requests to our Raspberry Pi. Different routers will have varying interfaces, but the concept applies just the same. In my case, I can access the configuration page of my router and go to the Advanced tab, then Port Forwarding, where I can create some entries that define a series of ports and local and remote IP addresses. We want to forward to our server any incoming connection on the ports 80 and 443 for the HTTP and secure HTTP. Additionally, if you want to be able to SSH into your server remotely, you have to include an additional port for that, which you can choose. This isn't completely without risk, and you should be aware of the possible threats it can pose to your system, so I will advise against it, unless you're knowledgeable in this matter. Once you have entered the data, make sure the configuration is enabled and save or apply the changes. Some routers might also require a reboot, but in such cases you will likely see a message asking you to do so. Everything is ready, and at this point you possibly want to set up a personal web page such as a WordPress blog. There are countless tutorials online for that, so I will avoid duplicating their content. I found a good example at makeuseof.com, which goes through the process in a neat way and is easy to follow. As an extra, I think it can be very interesting to do a quick speed test from your server to have an idea of the quality of service you will be able to offer. A very simple way of doing it is by downloading a Python script and running it. Connect to your server through SSH, download the script as indicated in the speed-test GitHub page and simply run it. It will test the download and upload speed separately, and in about 30 seconds you'll get a rough estimate of your server's internet capabilities. In my case, you can see that I have a regular cable connection with an okay speed, but nothing fancy really, about 75 megs down and 25 up. This won't be enough for thousands of simultaneous users, but so far it's going to be mainly for tests, and as it grows, I will upgrade the connection and most likely the hardware as well. Well, that's it for now. Hope that was useful, and stick around for more episodes.